Okay, let's try this again. Had a little interruption here. So let's see if we can get this going right. Am I, no, not that. Am I presenting still? Let's see. Okay, I think we're good. Okay, let's go ahead and get started. So for question number one, it says prove the identity. You need your either to have memorized your identities or have the sheet near you and know how to use them. Both of those are important. So let's make sure we're ready to roll because we're not. Okay, so we know that the sine of x minus y is equal to sine x cosine y minus cosine x sine y. And the sine of x plus y is equal to sine x cosine y plus cosine x sine y. If we add these two things together, obviously these two, the negative cosine x sine y and the positive cosine x sine y cancel out. So I'm left with sine x cosine y plus sine x cosine y, which is 2 sine x cosine y. That one's pretty straightforward. That's just knowing the identities. Okay, let's move to number two. Number two says prove the identity. So we're going to work with the left side again. So we just did this identity. So we'll plug in pi instead of x and x instead of y for the top and pi over 2 for y on the bottom. And what we end up with is, I guess I'll just write it out. Sine of pi minus x over sine of x plus pi over 2 is equal to sine pi over 2 cosine x minus cosine pi over 2 sine of y over sine x cosine pi over 2 plus cosine x sine of pi over 2. Okay. Sine of pi over 2 is 1. So that is 1, 1 times cosine x minus, did I do this backwards? No. I think I did this backwards. Yeah, I did it backwards. Sine of pi. There we go. I knew that looked funny. So sine of pi is 0 cosine x minus cosine of pi is -1. So that's -1 sine of y. I knew something looked funny there. Over. Now we have pi over 2. Cosine of pi over 2 is 0. So we have sine of x times 0. Put in parentheses. Sine of x times 0 plus sine of pi over 2 is 1. Cosine of y times 1. -1 is +1, so I end up with sine of y over cosine of y, which is tan of y. I could have used this space here, but I'll use the space for number 3, since we'll need it. All right. Like I said, I wish we were doing this in person so that y'all could tell me if I was moving too fast, but in any event, let's go. So they give us this. Cosine of x is 1/√10, and x terminates in quadrant 4. That always, well, it doesn't always, but it always means draw a graph. So draw a little triangle in quadrant 4. This is theta. And cosine of theta is 1/√10. So we have to figure out what the opposite side is. So root 10 squared is equal to 1, call that y. 1 squared plus y squared. Root 10 squared is 10. So 10 is equal to 1 plus y squared. Subtract 1. 9 is equal to y squared. That means that y is equal to positive or negative 3. Here we're in quadrant 4, so it will equal negative 3. So from there, now we can do our identities. Sine of 2x, or 2 theta, is equal to 2 sine x cosine x. In our cases, it will be 2 sine of theta is equal to negative 3 over root 10. Cosine of theta is equal to 1 over root 10. So we simplify 2 times negative 3 is negative 6 times 1 is negative 6. Root 10, 1 times root 10 times root 10 is just 10. Is equal to negative 3 over 5. That is the sine of 2x. All right. Cosine of 2x still equally easy, but a little more annoying. Cosine of 2x is equal to cosine squared x minus sine squared x. Now, theoretically, you could choose any of the cosine identities for this and get the same answer. This one just seems easiest. All right, is equal to cosine of x is 1 over root 10 squared minus negative 3 over root 10 squared. That is equal to 1 over 10 minus squaring this negative 3 over root 10 makes it positive. So the subtraction sign stays intact. So 1 over 10 minus 9 over 10, which is equal to negative 8 over 10, which simplifies to negative 4 over 5. All right. And lastly, tangent of 2x is equal to 2 tangent x over 1 minus tangent squared x, which is, well, I'll go down here, which is tangent is negative, tangent of this is negative 3 over 1. So 2 times negative 3 over 1 minus negative 3 squared. So because the negative 3 is squared, the minus stays intact. That becomes negative 6 over 1 minus negative 3 squared is 9. So 1 minus positive 9, which is negative 8, which is positive 3 over 4. All right. Make sure this thing's recording. Okay, we're recording. Just wanted to make sure. Just want to make sure. All right. Sorry, all kind of little interruptions here. Did I do it? Yeah, I did all of that. Okay, number 4. Number 4 says simplify the expression by using the double angle formula. So if cosine squared something minus sine squared something, we know that that is equal to cosine of 2 times whatever that something is, which is 44, which is cosine of 88 degrees. 5 degrees there. That's all we need. That's all we need for that one. All right, I probably should have written up here to save some space. Matter of fact, yeah, let's do that. All right, number 5, a little work on this one. You rewrite cosine of 2 arctangent of 5v as an algebraic expression. So We don't know how to take the cosine of 2 times the arctan of anything, so we draw a picture. You always assume quadrant 1 unless told otherwise. So if that's theta, if this is theta right here, then what we know is arctan, if arctan of theta, if arctan of 5v is equal to theta, this means that tan of theta is equal to 5v. So we do that. Tangent of theta, tangent of this is 5v, that's 1, because tangent is opposite over adjacent. So, of course, we need to find this hypotenuse. So 1 squared plus 5v squared is equal to h squared. 1 plus 25v squared is equal to h squared. So square root of 1 plus 25v squared is equal to h. I'll put it there. Square root of 1 plus 25v squared. Well, my writing's so little, I could just zoom it in. Okay. So now, so we know, we don't know what theta is, but we've solved the triangle. So the arctangent of 5v is equal to theta. And we want to know the cosine of 2 theta. Because the arctangent of 5v is going to give me theta. So the cosine of 2 theta, which is cosine squared theta minus sine squared theta. All right, which is cosine of theta is 1 over root of 1 plus 25v squared minus sine of theta, which is 5v over 1 square root of 1 plus 25v squared. That is 1 over 1 plus 25v squared, because I just squared it, it became the same thing, minus 25v squared over 1 plus 25v squared. Put them together and you get 1 minus 25v squared over 1 plus 25v squared. And believe it or not, you can't do anything else with that. Can't do anything else with that. That's pretty much what that is. Okay. I hope that you are having fun with this. I am definitely enjoying doing these trig problems. Use a half angle formula to find the exact value of tangent of 22.5. Okay, so what we know is if I multiply this by 2, this becomes 45 degrees. All right, so this is tangent of 45 degrees over 2. If you go to your formula, let's go to the formula sheet for tangent of theta over 2. This is the square root of 1 minus, square root of 1 minus cosine of 45 degrees over 1 plus cosine of 45 degrees. Oh, this will be fun. Fraction work. Cosine of 45 is root 2 over 2. Cosine of 45 again is root 2 over 2. Okay, I'm gonna try not to skip too many steps. I'm gonna simplify a little quickly on this. If you get confused, let me know. All right, square root of, don't lose your square root. 1 is equal to 2 over 2. So this is 2 minus root 2 over 2 over 2 plus root 2 over 2. Okay, so What we know about fractions is we can, if it's like this, we can cancel. So the 2's cancel. So this ends up being the square root of 2 minus root 2 over 2 plus root 2. Okay, now we're going to do a little math magic here. Change color. I'm going to multiply by 2 minus root 2 over 2 minus root 2. Okay, and what I'm doing is I'm getting, you're not supposed to have a negative root 2, a root in the answer. We don't want negative numbers in the denominator. We don't, not the answer. We don't want negative numbers in the denominator unless, you know, we generally don't want that. We don't want square roots in the denominator. So I'm multiplying by the conjugate to get rid of the root in the denominator. Okay, so we end up here with big square root of 2 minus root 2 squared. This is 4 minus 2 root 2 minus 2 root 2 plus 2 over 4 minus 2. All right, I feel like there was an easier way. I feel like there was an easier way to do this. Like I did this problem, there was an easier way to do it. But whatever. All right. So, because we're almost done. Square root of 4 plus 2 is 6 minus 4 root 2 over 2. Almost there. Divide both of them by 2. End up with square root of 3 minus 2 root 2. Okay. There's more that we can do with this, but we're going to leave it right here. Or better yet, what I'll do is I'll play with it, and I may come back. I may hop back on to show a simpler way to do this, because I feel like that answer is I may have overcomplicated this answer a little bit. There's an easy way to do it. But anyway, let's continue. All right, question number 7. All right, almost there. Yeah, we're doing good with time. All right, suppose sine of alpha is 4 over 5 and is between 90 and 180 in the second quadrant. Four over 5. We automatically know that that's -3 because it's a Pythagorean triple, a 3, 4, 5 triangle. Find the exact value of sine of alpha over 2 and tangent of alpha over 2. So that's, we'll call it alpha. Same thing as theta. So sine of alpha over 2 is equal to square root of 1 minus cosine alpha over 2. Yeah, that's right. So in our case, this is square root of 1 minus cosine of alpha is -3 over 5. 3 over 5 over 2. The algebra in this won't be too bad this time. Okay, so this is square root of 1 plus 3 over 5 over 2. So this is square root of 8 over 5 over 2. And let's say over 2 over 1 so we can see it. So the bottoms, we could cancel, but it's 5 over 1. There's nothing to do with that. For the top, 8 over 2, let's change this. 8 over 2 is the same thing as 4 over 1. So this ends up being this square root of 4 over 5 because the 1 over 1 goes away. So this is 2 over root 5 or 2 root 5 over 5 if we're doing it correctly. Boom. Because if I'm taking the square root of a fraction, that's the same thing as the square root of the top over the square root of the bottom. All right. So last one. Prove the identity. We love these. We love these. I love proving identities. All right. Oh, wait a minute. Tangent. I almost forgot. Tangent of alpha over 2. That is equal to square root of 1 minus cosine of alpha over 1 plus cosine of alpha. All right, so that is square root of cosine we've already established is negative 3 over 5. So 1 minus negative 3 over 5 over 1 plus negative 3 over 5. Okay, again, already established. The numerator is 8 over 5 over 5 over 5 minus 3 over 5 is 2 over 5. Okay, similar to last time, cancel. The bottoms can cancel. The tops also cancel either. And I end up with 4. That's 1. That's 1. That's 1. 5 over 5 is 1 over 1. 8 over 2 is 4 over 1. So then I have square root of 4, which is just 2. Okay, now we can get to the fun part, or the actual fun part. Well, pause here if you need it. All right, prove the identity. Cosecant squared x over cotangent x is equal to cosecant of 2x. We are going to go with the left-hand side. So, let me put this up. So, we have that, and we know that cosecant squared x, let's just write it out, cosecant squared x over 2 cotangent x. Cosecant x is 1 over sine squared x, and cotangent x is 2 cosine x over sine x. If you need me to show about dividing fractions, I can. But if you need me to do it, let me know. I'm going to just keep going. But if you need me to do that, then let me know. All right. So I have sine squared. Let's do it like this. So this is we know that this is a fraction divided by a fraction. This is the same thing as 1 over sine squared x divided by 2 cosine x over sine x. Same thing as 1 over sine squared x times sine of x over 2 cosine x. All right, keep, change, flip. Keep, change, flip. All right, the sine squared and the sine cancel out. 1, and then that's just sine x. So this ends up being, if I multiply them together, 1 over 2 sine x cosine x, which is 1 over sine of 2x, which is, which is cosecant of 2x. Well, that was fun, but easy. So we're done here. If you have any questions, definitely feel free to reach out, but I wanted to get these out to you as soon as possible.